Alrighty, let's see if we can run a real test. So this is our mainboard Pico 2W OLED screen. You'll see I've also connected a LED, and then I've got two testers here. I'll just quickly, I'm only going to use one to start with. So the red cable is in our main slot, and that's connected up here. This one is doing something else. Now you'll notice there's no USB. We've got our Brook. This one's the Gen 5X. This is a PCB of my own design, just so I can connect and control things easily. Now hopefully all we need to do is to connect here and then turn the power on. Now inevitably it pushes all the buttons at once. Not quite sure how to get rid of that, but anyway. You will see this has come on, and this has got a tiny bit of light through it, but you might not be able to see that. Now, what we want to do is to test the command history. This is Mortal Kombat Legacy Collection. It was not known for having the crispest responses when it came out, but we're getting there. This is indeed the unpatched version, so we'll see what kind of numbers that can generate. Now, I'll just quickly show. So you always, when you're testing, you need to kind of work out what's how your game kind of responds. So you can see no tests yet, 0 out of 100. We're looking at our main, which is the one on the left, the one that's sticking out a bit. We've got this little number here, which is a bit hard to see, but it's kind of flicking around 77, is how much brightness it's detecting underneath. And you'll see that there's a down arrow there. So when it's got a down arrow, it's got about 77. When we block, that drops down to 43. Okay, and so what you want is an area of the screen that's pretty consistently changes from brightness to darkness or vice versa. So go back to our website. We need to just change a few things here. So the first thing that I do, we make sure that our screen's set up right. So 120 Hertz, 8.33 milliseconds. That's how our PS1 behaves, PS5, sorry, behaves. This is my own creation. I've got a rule that tells me what percentage of the screen we're down. You don't need to do this if you're just working off raw results. Whoopsie daisy. But I certainly try to do it for all my tests. Now, because I've swapped to my actual board instead of the one that just came out of the box, the IP address has changed. So now we're on. So 128.33, and this is 91% of the way down the screen. Probably don't need to do that, but I will. What's more interesting is controller settings. So. The way this tends to work is these are milliseconds. So for the first 100 milliseconds, it will kind of read the brightness to see what's happening. So we're going to go from the blocking icon to the down icon. So we're going to do 100 trials. We're going to read for 100 milliseconds to kind of get a baseline. We're going to stop reading at 250, which will hopefully be enough. And we're going to cycle every 499, so two tests per minute. So if we're on at 100 and off 2 frames later, and then alternately we are 3p off. We just click in the other numbers that we want. So 3p from memory was our block button. Everything else should be good. A lot of this you can just ignore safely. So we'll go back to our screen there. We'll make sure we've got our starting point. You can see for Mortal Kombat 1, it's flat, which I don't prefer, and 2, it fades as it goes across, which I definitely don't prefer. Anyway, so we can either click on the start icon, the OK on our web page, or go to PT main and click OK. So already you can see numbers coming up. So this is how long after that 100 milliseconds of zeroing it's taking to get a response. To, I guess, warn, the LED is not quite as accurate as the number, in that for the number I check that it has 3 successive rises or falls before I accept it as real. Whereas for the LED, I don't have enough processing time to do that. So as soon as you get a rise outside of the kind of baseline that we set, then we change the LED color. So if there was any discrepancy between those two, I would go with the screen number each time. So while I've been talking, that is 100 trials right there. You can see we've done 100. It's averaging 108.71, but we can get a bit more detail than that. Now I might just quickly pull this down because it gets in the way. Again, the jigs of my own construction. Happy enough to share the 3D files if needed. We'll click Show Graphs. So our blue is our main. Sorry, the cables are back to front. And red was our one that we didn't really use. So we can see that this is where we start looking for things. So we zero baseline for 100 milliseconds, and then we start looking. So after about 100 milliseconds, we get our result. This is the summary of what our test did. And so they're actually nice tight ranges there. Okay, which is good. You can click on results and it'll display all the graphs. And so you can scroll through. If there were any that were a little bit off, you could go back and just retest at that point. So what it's done is it said for all of those tests, we are averaging 108.71 milliseconds, which is the number on the screen. Because we've told it it's 90% of the way down and we've told it how quickly it's filling that in, the actual result is 101.13 milliseconds. Okay, so that's a full test showing how I would go about testing for input lag pretty much from start to finish. So we can update the title and then save this, and then when we open it, you've got a log of everything that we've done. Okay, all of the tests. It just displays the first 255 milliseconds. From memory, I'm almost certain it'll save the most recent one, so you could theoretically bring that back, but I'm pretty happy saving the HTMLs. All right, so that is a test pretty much in 2 videos from start to finish.